There's a story we tell ourselves every time a rocket comes home, that the journey ends at splashdown, that the moment the capsule breaks through the atmosphere and hits the water, the mission is over, contained, cataloged, and closed. Families exhale. Mission controllers stand up from their consoles and hug each other. The world watches recovery helicopters lower toward the ocean, and we see the astronauts pulled through the hatch, squinting into sunlight they haven't felt in weeks. Social media fills with photographs. News anchors read success from their teleprompters. We declare it a triumph. We move on. That assumption is clean, comfortable. And in the case of Artemis II, it may be incomplete. Because between the moon and home, something appeared in the data that no one has fully explained away. Before we get to that, it's worth understanding what Artemis II actually was, and why it mattered in a way that goes beyond the usual superlatives. After more than 50 years, NASA sent human beings back around the moon. Not to the surface, not yet, but Artemis II was the first crewed lunar flyby since Apollo 17 in December 1972. 4 astronauts, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen, flew the Orion spacecraft on a trajectory that brought them closer to the moon than any human beings in half a century. The mission was not just a checkpoint on a program schedule, it was a reintroduction. Humanity remembering how to go somewhere it had almost forgotten how to reach. And by every official measure, it succeeded completely. Orion performed its lunar flyby. The crew completed their objectives. The spacecraft executed its return trajectory. Re-entry was nominal. Recovery was nominal. The entire architecture of the mission, the Space Launch System, the Orion capsule, the Deep Space Communications Network, performed within expected parameters. The official record is clean. And then there is the tracking data. In the hours following Orion's trans-Earth injection burn, the engine firing that committed the spacecraft to its return path, amateur and hobbyist observers using publicly accessible radar archive tools, along with several independent aerospace tracking communities, noted what appeared to be an object in proximity to the capsule. To be precise about what this means, this is not a confirmed NASA anomaly report. There has been no press conference, no official acknowledgement of anything unusual. What exists is a quieter kind of signal, unverified data from non-governmental tracking sources, archive requests submitted through standard public channels, and discussions within specific aerospace communities about return phase signatures that don't reconcile neatly with the expected debris profile from the service module separation. The anomaly did not make headlines. That may be exactly why it deserves careful attention rather than dismissal. The simplest explanations are always the right place to start. Deep space missions produce debris. The Orion spacecraft separates components during flight, fairings, service module panels, umbilical connectors. Some of this material persists in the vicinity of the capsule for hours or even days, following similar orbital paths because they were traveling at nearly the same velocity when they separated. From a ground-based tracking perspective, distinguishing a spinning piece of insulation blanket from a structured object is genuinely difficult. Radar cross-sections are imprecise. Signal returns can be misread. Objects rotating irregularly produce inconsistent signatures that can look, in raw data, like they're appearing and disappearing when they're actually just tumbling in the dark. That explanation covers a great deal. It is the right first answer. And it almost works. The detail that complicates it is the persistence. Debris fields from a service module separation typically disperse. They don't maintain consistent relative positioning across multiple tracking windows spanning several hours. The physics pushes things apart, not together. Thermal pressure, minute differences in velocity, the natural spreading of any field of separated objects, all of these forces scatter debris over time. What was noted in the community tracking data from the Artemis II return window did not behave like something scattering. It behaved like something holding its position. That is a different kind of physics, and it's what divided the conversation. One school of thought, and this is worth taking seriously, points to classified hardware. This is not fringe speculation. It is a recognized category of explanation in aerospace tracking discussions. NASA's Artemis program involves deep coordination with the U.S. Space Force and the broader national security space architecture. It is entirely plausible that Orion was monitored during its return by assets whose existence is not publicly documented. A classified tracking platform shadowing a crewed capsule during re-entry would appear in unclassified community radar logs as exactly the kind of persistent, structured proximity contact that was noted. This explanation is clean, it is boring, and it is probably the most underappreciated possibility in the conversation. But it introduces its own problem. If the contact was a known classified asset operating under planned coordination, why does the community tracking data show the gaps it shows? Controlled objects don't drop out of detectable range and reacquire at slightly different bearings in a pattern, consistent with something responding to the primary vehicle's movements. That pattern fits a coordinated system less well than it fits something less predictable, something whose behavior was driven by proximity to Orion, not by a pre-filed flight plan. And that is worth sitting with. The moon is not a sterile environment. That sounds like the opening line of something irresponsible, so let me be precise about what it actually means in the context of current planetary science. The lunar surface has been bombarded for 4 billion years by solar wind, cosmic rays, and micrometeorite impacts. It contains volatile compounds, water ice in permanently shadowed polar craters, hydrogen, carbon compounds, whose full origins are still being studied. Some researchers have proposed that the moon may produce transient near-surface phenomena that we have not yet fully characterized. Not life, not intelligence, but physical processes, electrostatic discharge events, plasma interactions with the solar wind, particle emissions from specific geological formations that could, in theory, produce detectable signatures near spacecraft flying within close range. Artemis II passed within approximately 200 kilometers of the lunar surface. That is close enough to matter. If any of these poorly understood near-moon processes are capable of affecting spacecraft systems in ways our current models don't predict well. This is speculative. It needs to be held carefully. But it is speculative in the way serious science sometimes is, not in the tabloid sense, but in the sense that our surface access has been sparse, our instrument time limited, and our models of the cislunar environment are still being actively revised with every mission that passes through it. What makes the conversation harder to close is that this is not the first time proximity anomalies have appeared in lunar mission records. Apollo 11 reported an unidentified object during its outbound journey, acknowledged by the crew, logged in the mission record, and later attributed to a separated rocket panel, though that attribution was made with reasonable but not definitive certainty. Apollo 13's crew described visual phenomena near the spacecraft during its troubled return, officially attributed to ice crystals from vented systems. Apollo 16's radar logged a persistent contact that was never formally resolved in the public mission archives. Each of these incidents was treated as isolated, routine, and explainable. Together, they represent a pattern that the public record has never quite assembled into a single coherent question. Artemis II may be the newest entry in a list that no one is officially keeping. Here is where the question changes shape entirely. Because until this point, we have been asking, what was the object? That is a question about identification. It has a finite number of answers: debris, classified hardware, natural phenomenon, sensor artifact. And eventually, one of those answers may close it. But there's a larger question underneath it, and it doesn't resolve as neatly. When human beings travel to a place as extreme, as old, and as physically unusual as the moon, and then return, is the assumption that they come back with only what they left carrying actually a well-founded assumption? Not in the biological sense alone. The medical literature on what spaceflight does to the human body is extensive and still being written. Fluid shifts, microbiome disruption, radiation exposure, immune system alterations, visual disturbances from intracranial pressure changes in microgravity. The Artemis II crew returned measurably changed. That is confirmed and expected. But NASA's planetary protection guidelines, some of the most rigorous in space exploration policy, exist precisely because the question of what crosses back with a returning mission is taken seriously at an institutional level. Those protocols govern not just biological material, but physical contamination, particles, compounds, and properties that should not cross certain thresholds without controlled handling. They were active for Artemis II. The capsule was managed under containment procedures upon recovery. This is standard, and it is worth noting that standard procedures only exist because the risk they address is real, even when it is small. What followed Artemis II home, if anything followed Artemis II home, may not be visible on a radar screen. It may be something more subtle, a pattern in telemetry that engineers are still reconciling with their models, an orbital perturbation too small to flag automatically, but too consistent to be noise. A thermal signature that doesn't match the expected cooling curve of a capsule at that stage of re-entry approach. Or it may have been a piece of thermal blanket tumbling slowly in the dark, catching radar pulses at just the right angle for just long enough to generate a question that has a perfectly ordinary answer waiting for it. Both outcomes are genuinely possible. That is not a failure of investigation. That is the actual state of the evidence. What is certain is this: Artemis II crossed a threshold humanity had not crossed in more than 50 years. And thresholds, in physics, in biology, in history, have a way of producing consequences that weren't in the mission parameters. The moon is not simply a rock. It is the closest extraterrestrial environment our species has physically reached. Its surface stores 4 billion years of solar system history in layers of regolith, impact glass, and ancient lava. Everything that has ever struck it is still there, compressed, preserved, waiting. When we go there, even when we only fly around it, we are not visiting an empty place. We are entering a record, And records, when examined closely enough, sometimes look back. There is something humbling about that. And something that should, if we are being honest, make us a little careful about how confidently we declare the mission closed the moment the capsule hits the water. The next Artemis missions will go further. They will land. They will spend days on the surface. They will bring back samples in quantities Apollo never reached. The opportunity to understand the moon more completely than any generation before us is real and close, but so is the opportunity to miss things, to be so focused on the science we plan to find that we fail to properly examine what we didn't anticipate. The community tracking data from Artemis II is not a smoking gun. It is a question. And the most important thing about it is not whether it proves something remarkable happened during the return from the moon. The most important thing is what it reveals about the limits of our attention, about what we are and aren't watching, and how carefully we are actually looking. We tend to imagine space exploration as a process of going out and bringing things back. Samples, data, images, experience. We design missions around what we intend to collect. But every vehicle that has ever crossed the boundary into deep space has also been, whether we framed it this way or not, a sensor, a probe of what is actually out there, beyond our models, beyond our predictions, beyond the edge of what we confidently understand. The mission doesn't only flow in one direction. It never has. Artemis II went around the moon. It came home. 4 people completed an extraordinary journey and are, by every measure that matters, safe. That is the story, and it is a genuinely remarkable one. But consider this. Human beings have passed within close proximity of the moon exactly 24 times in all of recorded history. 24. For a body that has shaped our calendars, our tides, our mythology, and our imagination for as long as our species has existed, we have barely grazed it. Our sample size is almost absurdly small. Our models of what this lunar environment does to hardware and biology over the course of a mission are still being corrected with every flight. It is entirely possible that something followed Artemis II home, and we simply weren't looking in precisely the right direction to see it clearly. It is also entirely possible that nothing followed it home, and every anomalous signature in the community data will yield a satisfying, ordinary explanation. The evidence, at this stage, cannot distinguish between those outcomes with confidence. What it can do is remind us that exploration is not a controlled experiment. You go somewhere unknown. Unknown things happen. Some of them you catch, some of them you don't, and the ones you almost catch. The signals at the edge of detection, the data that doesn't quite fit, the objects that appear and disappear in the margin between confirmation and suspicion, those are sometimes the beginning of the most important questions. So here's what I want to leave you with, and I genuinely want your answer in the comments. If something did follow Artemis II home, not a threat, not an intelligence, just something that came back across that distance alongside the crew, would you want to know? Or is there a version of this story where the not knowing is something worth protecting? I don't think that question is as easy as it sounds. And I think how you answer it says something real about how you believe humanity should move through the universe. If this is the kind of story that makes the sky feel less like a backdrop and more like a place with edges you haven't yet found, stay here. Because the things at the boundary of what we know are almost never nothing. And we are only beginning to understand what we brought back.